ratio and a rate. A ratio is simply a fraction. However, for a ratio, the units have to be the same. So let me give you an example. If I take 4 feet over 5 feet, this is called a ratio. Am I following me? Because the units are the same, like feet and feet, okay? Now, for a rate is different. Rate is something like miles per hour. If I take 50 miles in 3 hours, this is called a rate, okay? Like you're driving on the freeway, your rate of speed. So that's called a rate problem. So just know the difference between a ratio and a rate, okay? That's a rate and that's a ratio. Okay, now, proportionate is when you make two ratios equal to each other or two rates. It don't matter, right? So if I give you something like this, 1/3 is equal to 3/12. Okay? That's the proportion, okay? So when you put the equal sign between two ratios or two rates, now you have a proportion, okay? Now this is a true proportion, right? Because we know 1/3 does equal to 3/12. Isn't that true? No, it's not, isn't it?
No.
That's not true. It should be what? 9, right?
Right.
Now it's a true proportion. Isn't that a true proportion?
Really?
Okay, now it's true. Okay. Now let's move on. Now that we know what rates and ratios are. Now, this particular section, all the problems are story problems. Are you following?
Wow.
Not all of them. Not all, but a lot of them are. So look in the back of your section, okay? So everybody look at the back of the section where the homework starts. So look at, anybody had geometry in high school?
No.
Okay, so if you had geometry, it's not been that long. Wow. Wow. Now, 1 through 15 are simple proportion problems. However, the rest of it is all application, okay? And so some geometry. So we're going to start on the simple stuff, then we're going to move on to the application. Okay, now look at number 1. And that's on page 486. Now, we got a proportion. This is called a proportion. X over 12 equals 3/4, okay? This is a proportion. But what they want us to do is they want us to find the value of X and make it a true proportion. Everybody follow me? So now, anytime you have two ratios equal to each other, you can cross multiply, okay? Now, I'm going to show you 2 ways that we can do this problem. And I would recommend that you just cross multiply these, okay? One way is to cross multiply, okay? Now, when I cross multiply, I'm going to get 4x, right? And I'm going to get 12 times 3. Everybody agree? And then I'm going to divide both sides by 4, right? And everybody see what I just did? I cross multiply, right?
Right.
Now, 4 going to 4 times, so I get x, right? 4 going to 12, how many times?
3 times.
3 times. And what's 3 times 3?
9.
That's 9, okay. That one is 9. Now, the other way you can do these is find the LCM. So what's the LCM for 12 and 4?
12.
12, right? So multiply both sides by 12.
This is just another way of doing it.
Yeah, this is another way. I'm just giving you another way to do the problem. Okay, now, if you look over here, the 12 counts, don't it?
Right.
And then we get x. And then we get 4 going to 12. How many times?
3 times.
3 times 3 is 9. So
Oh,
it's up to
okay.
you. You can use this method to solve, or you can use cross multiplication. You probably want to use cross multiplication, but it's up to you. You decide which method you want to use. Okay? Okay, now, I want everyone to do number 14.